Alright, so in this problem, I have 4 to the power of x is equal to 40. So to solve this, I'm going to first start by taking the log on both sides. So now I have log 4 to the power of x is equal to log 40. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is equal to b times log a. So in this case, I have log 4 to the power of x, so I can move x to the front. So now I have x times log 4 is equal to log 40. Now, I'm going to go ahead and divide both sides by log 4. So then these two cancel out, and now I have x is equal to log of 40 over log 4. Now, log 40, this is the same thing as log of 4 times 10. Because log 40 is equal to 4 times 10. So I have this over log 4. And now if I have something in the form log a times b, this is equal to log a plus log b. So in this case, I have log 4 times 10, so this is equal to log 4 plus log 10, and now I have this over log 4. Now log 4 plus log 10 over log 4, this is the same thing as log 4 over log 4 plus log 10 over log 4. And log 4 and log 4, these two cancel out, so now I have x is equal to 1 plus log 10 over log 4. So now log 10, this is the same thing as 1. Log 10 is equal to 1. So now I have x is equal to 1 plus 1 over log 4. And log 4 is equal to 0.602, so now I have x is equal to 1 plus 1 over 0.602, which is equal to 1 plus 1.66, meaning x is equal to 2.66. Alright, so in this problem, I have x to the power of x to the power of 4 is equal to 64. So I need to find the value of x here. So for my solution, I'm going to first start by taking the power of 4 on both sides. So now I have x to the power of x to the power of 4 to the power of 4 is equal to 64 to the power of 4. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of n to the power of m. So I can switch the places of m and n here. So in this case, we can think of x to the power of 4 here as m and 4 as n. So if I switch the places of these two, I get x to the power of 4 to the power of x to the power of 4 is equal to 64 to the power of 4. Now I'm going to replace 64 with 8 squared. So now I have x to the power of 4 to the power of x to the power of 4 is equal to 8 squared to the power of 4. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So a to the power of 2 to the power of 4, that's going to equal a to the power of 2 times 4, which is equal to a to the power of 8. So I have x to the power of 4 to the power of x to the power of 4 is equal to a to the power of 8. Now I'm going to let x to the power of 4 equal to the variable y. So now I have y to the power of y is equal to 8 to the power of 8. And if I have something form a to the power of a is equal to b to the power of b, this means that a is equal to b, meaning y is equal to 8. Now remember how we let x to the power of 4 equals y. So if x to the power of 4 equals y and y equals 8, then this means that x to the power of 4 is equal to 8. So now to solve this equation, I'm going to take the fourth root on both sides. So the fourth root of x to the power of 4 is x, and so I have x is equal to fourth root of 8. So now to check, my original equation was x to the power of x to the power of 4 is equal to 64. X is equal to the fourth root of 8, so now I have fourth root of 8 to the power of fourth root of 8 to the power of 4 is equal to 64. Now the fourth root of 8 to the power of 4 is simply 8. So now I have fourth root of 8 to the power of 8 is equal to 64. Now this is the same thing as 8 to the power of 8 over 4 is equal to 64, meaning 8 to the power of 2 is equal to 64, and 64 equals 64. So this is right. Alright, so in this problem, I have x to the power of 3 plus x is equal to 10. So to solve this, I'm going to first start by subtracting 10 on both sides. So now I have x to the power of 3 plus x minus 10 is equal to 0. Now negative 10, that's the same thing as negative 8 minus 2. So now I'm going to switch the order of these and rewrite this as x to the power of 3 minus 8 plus x minus 2 is equal to 0. So now 8 is the same thing as 2 to the power of 3. So now I have x to the power of 3 minus 2 to the power of 3 plus x minus 2 is equal to 0. Now if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. So in this case, x to the power of 3 minus, x to the power of 3 minus 2 to the power of 3, I can rewrite as x minus 2 times x squared plus 2x plus 2 squared, which is 4, plus x minus 2 is equal to 0. So now if I factor out x minus 2, I get x minus 2 times x squared plus 2x plus 4 plus 1 is equal to 0, which is the same thing as x minus 2 times x squared plus 2x plus 5 is equal to 0. So now to solve this, I have two equations. I get x minus 2 is equal to 0, and x squared plus 2x plus 5 is equal to 0. So for x minus 2 equals 0, x is obviously equal to 2, so this is one solution. And for x squared plus 2x plus 5 equals 0, I can use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, b is equal to 2, so I have negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times a, which is 1, times c, which is 5, all over 2a, so 2. Now this is the same thing as negative 2 plus or minus the square root of 4 minus 20 over 2, which is equal to negative 2 plus or minus the square root of negative 16 over 2. Now the square root of negative 16 is the same thing as the square root of 16 times the square root of negative 1, and the square root of negative 1 is equal to imaginary number I. So negative 2 plus or minus the square root of, square root of 16, which is 4, times I. I is the square root of negative 1 over 2, which is equal to negative 1 plus or minus the square root of 2i. So two more solutions. Alright, so in this video, we're going to be solving the equation x to the power of x is equal to 8. So, at first glance, this problem may look challenging. So to solve this, I'm going to first start by taking the ln, or natural log, on both sides. So I'll get ln x to the power of x is equal to ln 8. And a helpful property that comes with logarithms is that if I have something in the form ln a to the power of b, I can move this exponent to the front, so this turns into b times ln a. So in this case, I have ln x to the power of x, and I can move x to the front. So now I get x times ln x is equal to ln 8. Now from here, I'm going to use another formula that states that if I have something in the form w of a times e to the power of a, this is equal to a. And this is something known as the W-Lambert formula. So if I take the w of something in the form a times e to the power of a, it's going to equal a. So in this case, I'm going to rewrite this as ln x times e to the power of ln x is equal to ln 8, because x is the same thing as e to the power of ln x. So now I can use this formula. So I'm going to take the w on both sides. So I have w of ln x times e to the power of ln x is equal to, what I have to do on one side, I have to do the other side. So w of ln 8. And this simply turns into e to the power of ln x is equal to, ln x is equal to w of ln 8. And then now I'm going to take e to the power of both sides. So I get e to the power of ln x is equal to e to the power of w of ln 8. And e and ln cancel out. So I get x is equal to e to the power of w of ln 8. So this is my value of x. If you haven't already, please make sure to subscribe, leave a like, and share this to any of your friends and family members. And I have a lot of problems like these on my channel, so please make sure to go ahead and check them out. Thank you guys for watching.